Good evening and welcome to the BS and Beer Show. BS stands for Building Science. Tonight's topic is wood foundations. We have a couple of excellent guests tonight, Mike Gerton and Jake Bruton. Tonight I am drinking a foul-mouthed brewing dry stout. It's actually very good, local Maine beer. At the BSM Beer Show, we encourage local groups. There are groups scattered all over the country now, and Greg O'Byrne is in the audience tonight. He has a BSM Beer group in Australia. Feel free to contact us if you want tips for starting your own BSM Beer group. We would like to thank our media partners, Green Building Advisor and Fine Home Building Magazine. And yeah, I'm looking forward to the discussion tonight. I'm going to turn it over to Kylie from Green Building Advisor to talk about the show mechanics.
Hello all, I'm Kylie Jacques. I'm the senior editor at Green Building Advisor. I'm drinking a black cherry seltzer water, and I'm just to tell you that if you're new to Zoom, you're going to find the chat box at the bottom of the screen, and when you make comments, make sure that you click all panelists and attendees so everybody can see your questions and comments. And if you're on a mobile device, you might have to do this each time. Tonight we'll have an introductory presentation from Mike and a panel discussion amongst the six of us, and that will be followed by an audience and panel discussion where we'll take your questions. We'll wrap up at 7:30 promptly, and the video recording of tonight's show is available at Green Building Advisor come Sunday. And we encourage you to continue any comments and conversation over there. All past shows can be found on YouTube through a link at the bsnbeershow.com. I think that's all I have to say, and Emily's going to give you a few more announcements.
Hi guys, Emily Mottram, architect here in Maine. I'm continuing on with my wine snobbery and having a red blend from California because it's cold and it's past beer time for me. So tonight I'm going to do a couple of announcements. First is the Fine Home Building Summit, October 26th through the 29th. We also have the Passive House Maine Fall Forum on October 21st through the 23rd. And the Maine Indoor Air Quality Council Forum, October 27th through 29th, and they are all online, so you guys can join in on those. We have the Sion House Tour on November 7th, tours of 4 high-performance homes, including 2 by the former BS and Beer guest Bob Swinburne and Mindell and Morse builders, Ted Benson of Unity Homes. So a couple of our supporters are going to be on there. And last but not least, and I'll put all those links in the chat box for you guys, is book club. Let's talk about book club again. Oh, yeah. Thank you for everybody for joining us on the last book club. It was great. We had a great topic. This time we're going to read Healthy Buildings by Joseph Allen and John McComber. So we'll put a link up on the BS and Beer Show if you want to join in and read, and we'll have a discussion on this. I think right before Christmas so that everybody can have off for Christmas break. So join us on book club. Now it is over to Travis to introduce our guests.
Well, hello. Yeah, I'm Travis Brungart here in Kansas City drinking a BKS Artisan Ales. My other car is a Time Machine, which is a delicious sour that Emily would hate, which makes me love it all the more. I have the privilege of introducing a couple of great guests tonight. And before I read their bios and tell you more about them, I would like to start by introducing Mike Gerton, who I don't know well, but I am excited to have back on the show. Mike, what are you drinking tonight? What's going on? You got anything you want to tell us about yourself before I just read your bio?
Yeah, don't read the bio. How's that?
Oh, okay, that's solid.
That's it. There's no point. I mean, it doesn't really tell anybody anything they need to know. I'll tell you the portion of my bio which is relevant to tonight when I show the little slide presentation. But I'm drinking 100% unfiltered well water out of my well. That's what that's my favorite beverage. It's what I drink daily, even on weekends and after work.
Impressive. And that's a very well-maintained well from what I've seen on Instagram. You were on it with the well maintenance, man. That's impressive.
Luckily, I haven't had to use do any work on my well. It's just all of my tenants I've had to deal with lately.
If you guys aren't following Mike Gerton on Instagram, you're missing out. I saw him shimmying down a well shaft just last week. There's a lot of good stuff on there, which you can also say about Jake Bruton, my friend Jake in Columbia, who has all sorts of madness going on. What are you drinking tonight, Jake?
I am having an old fashioned with some Luxardo cherries in it that Travis sent me, actually.
Nice.
My wife loves
They
those
are
cherries.
delicious, too.
I am not surprised that you enjoy them too. So do you not want me to read your bio either? You want me just to make
No,
some
I like it when you talk about me. I'll just sit like this and listen. Go right ahead.
The builder and remodeler Jake Bruton is the owner of Aero Building in Columbia, Missouri. At Aero Building, Jake works to help ensure, he doesn't get all the credit, he helps to ensure that all the company's houses are built to last and that all are energy efficient. The company has a collaborative spirit and believes that project development should be between the builder, architect, and the client to help ensure that the final product is a good home that will not only, is a home that will not only look good, but feel good to live in and stand the test of time. You can visit him at aerobuilding.com. That's not bad. I feel like we can punch that up a little bit. There's no scandalous data in there. We'll have to reveal that tonight as the show goes on.
Okay.
Well, instead of starting with Jake, let's have Mike begin with his introductory presentation to kind of teach us all a little bit about this topic. Mike?
Sure, I'm going to share my screen. I guess that should work, right? Oh, host has disabled me. Oh, I've been disabled.
I didn't do that.
Disabled screen sharing.
Now is the portion of the show.
Now it
Somebody
should
else
work.
did that, yeah.
Okay, now it should work. So you should all be seeing a permanent wood foundation slide. Is that coming up right? Good.
Yep.
Okay. So I'm just going to do, well, the more I've dug into this in the last, probably week on and off putting this together, I've realized that this could really be an hour-long thing, but I'm only going to do it really quick. So I'm going to go through things quickly just to kind of set the stage, and that way we can talk more about things and questions a little later on. So the way a permanent wood foundation, now it's called permanent wood foundations. They used to be called all-weather wood foundations back in the 60s and 70s and when I did them in the 80s. But it's using pressure-treated lumber walls that sit on footings. Footing is made up of pressure-treated lumber as well as a level of graded stone or gravel base. There are prescriptive designs in the code book. There's engineering design information. I'll go over some stuff about that. And then there's some certain conditions for use. The first documented use, I found a good site. In fact, I sent Kylie a long list of resources, website links that I've used and found useful. So she's going to be sharing that, I guess, on the Green Building Advisor website, I guess. Is
right, along with the posts that will follow up on this show.
Okay, so you'll be able to find a lot of the information I'll be talking about here. But the first use was in 1937, and then they ended up moving the building a number of years later. So they pulled the whole foundation out, according to the report on that. And they said it was perfectly fine. They put it back in, and it's still used as an office building today. In the 60s, I won't go into the whole history of where this came, where this all came out of. It had to do with FHA and HUD and some changes to the flooring you could use in an FHA approved house at the time. But a lot of R&D was done in the 1960s. And I only learned this last night when Mark Martinez called me up. He saw my Instagram post about tonight's BS and beer. And he said, "Hey man, you really tweaked me on this." And I go, "What?" He goes, "You brought back some old memories." He said he was one of the test contractors for developing the whole all-weather wood system. So for any of you who aren't familiar with Mark Martinez, he now runs a company called Martinez Tool. He was a framer and custom home builder back in the 60s and 70s. He went on to start the first titanium hammer, the stiletto, and then now he does a lot of different hand tools between squares and hammers, other striking tools. Anyway, so I quizzed him a little bit. We spent a little time on the phone. He said they're hands down the best foundation on the planet. He said he built a whole neighborhood of them. He's been monitoring them because he still lives in the area. He's been monitoring them since the 1960s, and even in the seismic zone that he's in, they all function well. And he said the testing they did, even back then, showed that they performed better than concrete foundations in seismic zones, which is interesting because seismic zones are one of the restricted areas where we're not allowed necessarily to use them. So anyway, a little background there. And this is an old 1973 article put out by the Concrete Association as soon as these all-weather wood foundations started making an impact in the market in the late 60s and early 70s, when the first publications came out on how to install them. This was before a lot of uniform building codes had adopted them, and there wasn't even a whole lot of enforcement of codes back then. The concrete industry was really afraid that these all-weather woods were going to have a big impact on the market. My own experience goes back to the mid-1980s. My father wanted to put a shop. He was a motorhead and wanted a car shop in the back of his house. This is my parents' A-frame house. My father was not a contractor, but he was a mechanical engineer who subscribed to the Forest Products Lab. Back then they had a catalog that they mail out every year of all their free government publications, and he saw this thing about all-weather wood foundations, and he said, oh, that might be a good idea for my shop that he wanted to build. So we went ahead and built that. So I still monitor it. I took this picture yesterday, and it's still working. You can see the T111 that's on the exposed portion, but from this point down, from the T111 down, it's all a pressure-treated lumber, 2x6s. We did a few things that weren't in the prescriptive guide that turned out to be a little kind of wrong, only that we poured an 8-inch slab first and then set the walls on the slab. So we don't have a good, other than the anchor bolts we have down, the soil pressure isn't retained by anything. I'll show you some details on the way it should be done later. So I took a shovel just because I haven't checked to see what's happening down below grade, and I dug down about a foot and a half. What you see here is the upper portion is the actual permanent foundation. There's a 1/2-inch plywood, an 8-inch wide plywood strip that goes down to this orange line, and that's applied over the top of a 6mm poly, 6mm plastic film, which was the way this was waterproof, which is still in the code book today. And you can see right there a little bit of the plastic behind the dirt where I punctured through it, which I shouldn't have done. So even after, what's that, 34 years, the plastic's still in good shape. What you see up here is this little white line is actually the silicone sealant, which is supposed to seal the top of that plywood. The soil here at my parents' house is actually the worst possible condition. I took a scoopful, and I have it in my hand here. It's a silty clay, which is very poorly drained, and it's what's not recommended for permanent wood foundations. So even with that said, this, in the worst of situations here after 35 years, is still working, and I don't see any problem with it going forward. On the inside, it's all covered with plywood panels, and when I pull some off, it's, the plywood's still fine. From that experience with my father, I decided to try it in building homes for a couple of different reasons. And this is a shot of me and one of my business partners in about 87 or 88. We were building apartment buildings and condos in the city of Providence in infill lots. So the reason we use permanent wood foundations were a few reasons. One, we didn't want to have to dig out and have to fill off site and then bring it back in order to get a wide enough area for forms people to work. We could dig a fairly narrow trench, only about 2.5 feet wide, then put in crushed stone at the bottom, and then put in these panels, which we built off site. So security was also a problem. We built 3 or 4, like 4 and 5 unit buildings this way. We ended up backfilling on both sides. We insulated with some, you can see back in the back corner of the foundation, with some EPS foam in there and then under the slab, and then we just poured a concrete slab and then built on top of that. Buildings are still doing fine after, well, almost, 32, 33 years, I guess. Back then, this was approved by the CABO code. And when we proposed this to the city of Providence, the building department there didn't want us to didn't want to touch it. They said, we don't know anything about these. We've never seen them. We don't know. You know, you're going to have to talk to the state building commissioner to see what's up with using them, even though it was in the code book. So my business partner and I went to see the building commissioner at the time. Just so happened he sat on the code hearing committee that heard the proposals back in the late 60s, well, actually early 70s, early mid 70s for the all-weather wood foundations to be incorporated into the KBO code. So he was a wealth of information, and he was 100% behind it. He thought it was a great idea. I'm just going to jump over to the building code where it is now in the 2018 code. Under their application section for foundations, they give us two pathways to follow for using permanent wood foundations. One is using an American Wood Council Permanent Wood Foundation Guide. That was dated from 2015, and it's a design specification. It's kind of based on the NDS, a National Design Specification. Or you can follow the IRC sections. The IRC has limitations to it for backfill and for height and all that, whereas with the design specification, an engineer can design has a lot more freedom to design based on site conditions and everything. And when you open up that design guide, of course, for us contractors, we just scratch our head when we see all this kind of symbols and math in there, and we just say, you know, that's for engineers. So if you got an engineer involved, there's a lot of things you can do with these. But if you're going to go by the tables, you're restricted to the prescriptive measures, which are based on that, but they just took those engineering calculations, boil it down like they usually do with code, make it real simple with tables, illustrations, sections, and then some language in the code itself. So for the footings themselves, you can use either concrete footings, like you see on the right, or what I've done with the ones I've used are gravel or crushed stone. And so here's a situation where my friends were just running out a compactor over about 6 or 8 inches of crushed stone in a trench, and then we just set the footing plate on top of that. So that's all you need for footings. There's some design specs in the code. It calls for a 2x8 pressure treated plate, and that's actually part of the footing. They call it the pressure treated footing plate, and that will sit on either the gravel or crushed stone, and they give some prescriptive measurements there, 16 inches wide and 6 inches tall as a minimum. And you'll notice the interesting thing is when they measure for frost line, it's measured to the bottom of that footing. It's not to the bottom of the pressure treated plate, it's to the bottom of the crushed stone. And that opens up some opportunities later on. I'll show you when I show you some garage details. The materials for the wood foundation walls themselves have to meet certain specifications. The American Wood Preservers Association, there's some information in the code. I won't go into all the details. The basic on it is we need to use what's called ground contact heavy duty use, which is, I think it's heavy duty. Well, it's called US 4B, or I'm sorry, UC, which stands for use category 4B. And then that would be, some of the common treatments are going to be 0.60 CCA. Even though CCA lumber was not really outlawed, it was with an agreement between the AWPA and the EPA. It's just not sold for general residential purposes. However, for foundations, it's one of the preferred treatments. Another is a 0.31 copper azole -B or ACQC or ACQD with a 0.60, and those point numbers are the retention rate of the treatment chemicals in the lumber. And that would be for both your treated lumber, 2x6s, 2x8s, which we use for the walls, and for the plywood, which would sheathe them. After the treatment's done, it has to be kiln dried, KDAT, kiln dried after treatment. So sourcing these materials can be a little challenging. Most lumberyards aren't going to carry this stuff stock, so you're going to have to special order it and bring it in, which I imagine today with the trouble with getting lumber in general is going to be a real challenge. All the fasteners below grade have to be stainless steel. Back in the 60s and early 70s, they were doing them with galvanized steel, and they found that it just would not stand up. The code has an illustration in it, and It's just basically 2x6 walls. You'd be framing that at either 12 inches or 16 on center. And this would be for a roughly an 8-foot wall. Single bottom plate on top of that 2x8 foundation plate, and then a double top plate, which can be either pressure treated or not, because that would be, of course, above grade. The maximum backfill using the code now, which was not the case back in the in the old Cabo days when I was building them, we're limited now with the code to 4 feet or less in backfill. So that means the backfill area can only be up to 4 feet prescriptively. Now there are other things you can do. I'll show you some other solutions prescriptively that you could go a little taller than that. Then there is a table in the code which gives us the stud spacing based on the height of the backfill, and that also ties in with the thickness of the sheathing. For the most part, the sheathing that you're going to use will be either 1/2 inch CDX plywood or 5/8 inch. And those would be pressure treated. And again, the spacing and the height of the backfill would predicate what that thickness is going to be. Those treatments are still going to be that same retention rate. It's going to be that underground or ground contact UC4B treatment level. And then the damp proofing and drainage, they have sections in the code which address that, because that's always a concern. Of course, that would be a concern whether you're doing a regular concrete foundation or a block foundation or any other type of foundation. All the joints have to be sealed with a sealant, caulking. And then minimum is a 6 mil poly over the face of the wall, just a little bit above grade. And then that maybe an 8 or 12 inch wide pressure treated plywood strip to terminate that plastic. And then your backfill is important. They talk about the backfill. It has to be gravel or crushed stone, whatever your footing base is. You have to bring that up about 6 inches wide or up to a foot wide on the backfill portion on the side wall of the foundation. A minimum of 1 foot if you have well-drained soil. If you have poorly drained soil, then you have to go up 2 feet, basically halfway up the backfill if you're going up the 4 feet maximum. I would go, and today if I was doing one, and ones that I have planned in the future, I'm going to take the same measures I take now for even concrete, self-adhered membrane or a fluid applied coating over the plywood walls, and then a drain mat over that or a drain board, and then putting in good footing drains. Those aren't all required by the code. Minimum code is just that 6 mil poly, which just seems a little bit sketchy to me, especially if you're going to have a living space on the inside of the basement. And then I like to go with an underground gutter on top of that, which is just some EPDM or some PVC over your exposed portion of the foundation down over some slope grade, and then putting some river rock on top of that to cover it. And that's just a good detail to push the water away from the zone of backfill against the pressure treated wood foundation. Now this I use for ICFs, I use it for concrete, I use it for block. It's just a good measure with good drainage. As far as backfilling, you don't think of backfilling as being a code section, having the code talk about how to backfill a foundation, but it does with regard to all weather wood foundations. And this is because that bottom of the foundation can kick in, especially the wood being lightweight and just sitting on a gravel or crushed stone footing if you'd go that route. So with that in mind, they give us 2 options. One is to use a pressure-treated wood frame floor system, basically 2x4s, which run either continuously or with a header board in the middle, which is going to resist that soil pressure at the bottom of the wall, or going with a concrete slab, which will key right in with the bottom of the stud. So either way is going to work. If you want to avoid concrete altogether, then going with the pressure-treated wood would probably be a solution there. There is another alternative for designing the wood foundations. This is the SPFA, the Southern Forest Products Association's prescriptive guide for permanent wood foundations. Now, this is not a code, let me put it this way. This boils down a lot of what's in the American Wood Council design specification into prescriptive measures. But because it's not referenced in the code, you would, if you want to use this as a guide, you should bring it to your local code official. It purports that when this was written in 2001, or updated in 2001, that it would comply with the IRC codes up and through the 2006 IRC. There really aren't any significant changes with the 2018 from the 2006 with this. If you follow the guides in there, you can backfill at levels of 48, 60, 72, and all the way up to 86 inches, so you can get taller backfill. It gives us stud options for 2x6 and 2x8. Going taller with the backfill, you need 2x8s. And then the stud spacing will be based on a number of factors. It would be based on the soil backfill, and it would be based on the type of sheathing that you're using, whether it's a half-inch, 3/4, or a 5/8. Excuse me, half-inch, 5/8, or 3/4. The thicker you go, the wider spacing you can have on the studs. And then they have separate tables for whether you're going to go with a 1-story building or a 2-story building. And then they give construction details for all kinds of other things that you want to be concerned about. Before you backfill, in addition to having that slab or the wood frame at the bottom, you also need to have the first floor deck framed and in place and anchored to the foundation, because that's going to resist the foundation tipping in at the top. How long are these going to last? It's always a question that I get. Well, if you go with a woolmanized pressure-treated lumber, they have an actual program for permanent wood foundations, and they'll warranty it for 75 years. Well, I don't know what you do after 75 years, but, you know, they do give a 75-year. Just some general pros as a stepping off point for our discussion when I wrap up the next couple of slides. Some of the pros and why I like them anyway is construction schedule and being able to control that, particularly if you have in-house labor. That's one of the reasons why I used them in the 1980s and the early 90s, was because we had a crew framing houses. We could frame the panels off-site, bring them in, stack them up, nail them together. We would dig in the morning, set the panels in the middle of the day, and we would backfill by sundown. That eliminated the need to put a chain link fence around the site as a hazard precaution for people to fall in the excavation on site. So that was for those infill sites in a city. They say they're economical. There's some studies from the 1970s showing they're anywhere from 10 to 20% cheaper. I don't know how that will relate today. I haven't done a calculation to figure that out. For some people who want to get away from using concrete in their homes, it's a good way to, or one option I should say, to eliminate concrete. For winter construction, which was another thing that we encountered on some of the buildings I built, where concrete is limited on the temperature we could pour to, or we'd have to use heating mats or other types of insulation over the poured foundation in the middle of winter. We could put these panels in, and as long as we didn't have frost in the backfill soil, again, we dig it out in the morning, set the panels, backfill it, and it was, you know, in the 10 degrees Fahrenheit, 20 to 25 degree Fahrenheit range. And as long as the soil didn't freeze, we were using good, well-drained gravel anyway. We didn't have to worry about the limitation that concrete would have presented. Site access problems, particularly with additions. If you're doing an addition in the back of somebody's house, you could go in with a small machine, dig a trench that's maybe 16, 18 inches wide. You could put, if you're only going down a little bit, you know, like 3-4 feet, you could put crushed stone in the bottom. You could set the panels in. You could backfill it without doing a lot of site disturbance. And again, they can be panelized off site. Some of the cons that people mention about permanent wood foundations are the longevity, the perception in the local market amongst home buyers as well as home inspectors, and the water resistance. Some people are concerned about that, which I think can be placated pretty easily if you do good water management. And then, of course, as I mentioned, the sourcing of the lumber. There's also some limitations in some high seismic zones. You're not allowed to use them. And in very high wind zones above, I think you can use them up to 120. But once you get into 130, 140, 150, which is really only going to hit the real shore areas of some coastal parts of the Carolinas and parts of Florida, where they're mostly building slab on grade anyway, so they're probably not going to be using these. Unsuitable soils, if you get in areas where you got expansive soils, you can't use these. And of course, local code restrictions, because a lot of building departments just don't like the idea of this. Insulating the walls once they're framed, there's a couple of details which are going to make you all scratch your heads, and I'm still scratching my head over these. This is from the American Wood Council's design specification. They give one detail. Now look at this. Interior, they show a vapor barrier, plastic, over, this is loose fill like bad insulation or cellulose. You put a class 1 vapor barrier down 1 foot from the top of your backfill zone up on the outside. Then you do a horizontal parting the insulation, and then you go down a little bit on the inside face of the exterior plywood. And then below that, you just pack it with insulation. The other detail, the big difference there is they show a vent space, a 2-inch vent space between your bad insulation and the plywood, and then a 2-inch space down at the bottom between your bottom plate so that air will flow back there. Now, we all know what that presents as a potential problem, particularly in humid climates in the summer. We can talk about that.
The mold zone?
Yep, mold zone. Code book has the almost identical detail. They show a 2-inch air gap between your insulation all the way from the footing up to the top. Now, the Journal of Light Construction had an article by a contractor who uses these regularly, and he takes an approach which I think today would be more in line with current building science, which would be using exterior insulation on the outside of the wall, outside of the plywood. And that way you're warming that condensing surface. Now that would be depending on what your ambient soil temperatures are, as well as your local conditions. And this contractor then goes in and puts a little shot of spray foam down at where the slab is, where it touches the, where any fill insulation would be. And then he does a damp spray cellulose inside of that, and been doing it that way for years. Now, on since there's just a couple of final things on practical use ideas. And this is just things I've pondered over the last few years. I have not done this. But ranch style homes, even though raised ranch style homes, they're not, well, they're pretty popular here in my area, even now. They were really popular in the 70s and 80s. This is where you have a half wall, usually poured 4 feet down out of concrete, and then you build a knee wall on top of that, a little frame wall on top of that. That is a potential problem structurally anyway, just to begin with, because now you don't have anything retaining that concrete wall other than the fact that it's concrete. Hopefully it lasts. But imagine a wood frame wall, and this is one of the details in the guide from the Southern Pine Council, where you bury down the bottom of that footing foundation, wood frame wall, permanent wood foundation, a little bit under grade, below grade. And then you would frame that all the way up full height, whatever, 8-9 feet, to get you your headroom that you wanted. And then, although they showed a concrete or a wood framed floor system, you could really do a concrete-free slab, with foam insulation and the concrete, figuring that the soil on the inside, if you've buried the inside edge of that permanent wood foundation by, say, 4 to 6 inches, that should be enough, but you have to check on this, to prevent the bottom of that wall from kicking in. And then you could just cantilever your wall right over the top. So that would be a full frame wall with a raised ranch. They have a detail for garages in that permanent wood foundation design and construction guide from the SFPA. And this shows foundation wall, or I should say the perimeter walls of your garage being framed out of pressure treated lumber, down a minimum of 9 inches below grade, and then backfilled on the inside and the outside up to the roughly the same level, and then keying in a concrete slab for the garage. So you can imagine that being framed all the way up on top of the crushed stone footing. You'll notice here, and this will get to some things we can talk about during our discussion, that the footing itself, because it's a crushed stone footing, you would put the crushed stone down 2 frost lines. So this could be down 2, 3, 4, even 4 feet, but the frame wall only has to go down that 9 inches and then frame it up from there. So you could imagine taking this, as opposed to it being a garage, take that same detail, put a crushed stone foundation down below frost line, make this your house, and instead of this being a concrete slab, make that an insulated concrete free slab, and then the pressure treated walls are your frame walls for the house. And then this I'll finish up with. This was a sketch that I've been working on for my next own personal house, which is a combination of frost protected shallow foundations along with the permanent wood foundations, using a concrete free slab arrangement, taking a pressure treated 2x6 wall on a 4 to 6 inch crushed stone compacted footing down where it's 12 inches below grade, which in my zone is the requirement for our permanent wood foundations, where it extends up 6 inches above grade. So basically an 18-inch frame wall, just drop these in as panels, then insulate the outside. Here for my zone, I only need an R4.5, which is kind of crazy, in a 1200 with a 1200 air freezing index. Just do some good water management, a termite shield, and then I would run the insulation over the gravel on the inside, compacted all nicely, and then 2 layers of 3/4 subfloor that I would extend over the top of that permanent wood foundation wall, nail that down so it ties the whole thing together, one side to the other, all 4 corners of the foundation. And then on top of that, I could build whatever I want. I could do 2x6 construction, I could do double wall construction, whatever needs to be done. So
poured in place concrete on top of that?
Yeah, pour right over it. Yeah, put ICFs on top of it, whatever you want. I know Mike Maines, he intrigued me because I know he said he's toying with some ideas, so I'm interested to see what he has to say. And then again, just to reiterate that I sent a bunch of my resources, and this is just 1 of 2 pages, over to Kylie, and she can share those with everybody. So I'll let you guys take over the screen, and we can take it off from there.
How about I give
Mike, that was awesome. Yeah.
quick introduction to my limited experience with these. If you guys are okay with that, I went straight into talking.
Go for it. No, go for it.
So my father built one of these for our family to live in 1978, and I was actually really happy, Mike, one of your slides, the pros and cons. Speaking of which, I had a long conversation with my dad this week. He was helping me install some flooring at my personal house about this, and I invited him to come on. He said, "Why would I want to sit and talk on the computer?" Just so we're clear, he just got cranky and said no. So I did ask. So in 78, he was managing a lumberyard and decided that it was time to build a house for his family. And he, just like Mike said, they were starting in February. And so he was worried about being able to pour concrete. And he didn't know how to pour concrete. And he didn't want to have to pay for a concrete guy to come on site. So he hired one carpenter to help him with this house in nights and weekends. And so we had Mike called it a raised ranch. I had never heard that term before. I had always thought of it as a disgusting split level.
Yep, it goes by that name too.
Thing, yeah.
And with that same overhang on our house, which I also took an extra 20 minutes this week to drive by. It's still there, and it looks like it's being well taken care of. I was very happy to see that it was still there because I hadn't been by in a while. The carpenter that helped him build this house, then went on to build 5 or 6 in what people thought was a cost-effective subdivision at the time, west of town. And in talking about it, I realized that I've worked on 2 of those houses that carpenter went on to build after learning how to do this with my dad. And so I called one of the clients that used to live in one of those houses. Her name's Sarah, and I asked this week, and she said they moved out a few years ago, and she said she might have a basement remodel for me too, which was exciting. But she said they moved out a few years ago, and she said that it was the warmest and driest foundation she had ever lived in. And it also was a nasty split level. The difference between the 2 that I've worked on and the one that I lived in when I was a kid, the one that I lived in when I was a kid had a concrete slab. It was a walkout, and it had full daylight drain tile. The 2 that I've worked on, one of them is a concrete slab, and the other one has the pressure-treated floor joist basically in it instead of having a slab. And that's the one that I did a bathroom remodel on in like 2009. Didn't even think anything about it at the time. I was just like, well, that's weird. Why wouldn't they put in concrete? And left it at that. So I think that it's a very interesting thing. I was glad that Steve was here as well, because I think that the argument about concrete, that, you know, the 3 of the last 4 houses that Steve and I have built together, we deleted the slab in one to save concrete. We put the smallest basement possible in to save concrete, and we're deleting a big section of the concrete now to save concrete and not use as much concrete. So I think that it's something that's very interesting, and I think it's something that is just far enough out there that I'd have a real hard time trying to sell it to a client without smirking.
You know, interesting thing I found just in the years that I used them back in the 80s, it was actually used a lot more in the 70s, 80s, and even the early 90s. And I think using permanent wood foundations has fallen off. Areas of the country where you still see them used quite a bit are in the Dakotas, Minnesota, Michigan, and actually in Missouri. So you're not too far out of the range of where the lumber sources are readily available on the ground at lumber yards in those regions where you are, Jake.
You think that the that upper section of the country is excited about using because of the rural nature and the travel to ready mix plants?
That, I bet that's a good part of it. Yeah.
Yeah, a friend of mine who's a carpenter now grew up in northern Maine in a raised ranch. His dad built a lot of homes up there, and then moved to southern Maine and built more there. And he used a lot of them because they were a foundation he could build himself without a sub and cost less. The one my friend grew up in did experience it didn't fail catastrophically, but it definitely pushed way in. And Armando has commented a few times about expansive soil not being a good mix. So just I think the whole drainage aspect is probably even more important. Like just with concrete, you get some built-in resilience from soil pressure just because it's so strong, but you should be doing freely draining backfill and redundant drainage systems and waterproofing and everything with concrete. So just do the same with wood, and that should take care of the problems, right? Or do you think expansive soils could still be an issue, or poor drainage could still be an issue?
I think poor drainage is an issue for anything we put below grade. I think that was like when Mike was showing that, I think that's one of the most important points of the whole conversation is if we're going to bury it, we may as well do absolutely everything that we can to keep it from having challenge or being challenged by water. Also, Mike, that EPDM nailed at grade covered with gravel, that's genius. I've never seen that before. Thank you. I'll steal that.
I stole it from Peter Yost many years ago.
Comes full circle.
Oh yeah. No, you always learn. I don't know. There's nothing I know that I didn't learn from somebody smarter than me. So
Yeah. Same here.
Yeah,
Doug Horgan just said Peter Yost stole it from Bill Rose, by the way.
It's a quick question just in reference to Mike's presentation. Mr. Martinez, I missed his first name. Where does he work? What city or state?
He's in California. I forgot what city he's in. I could look it up in a minute. He has an almond farm. I think it's an almond. I'm pretty sure it's an almond farm out there. In addition to his fabrication facilities. But yeah, he said he's in a seismic zone, and these houses have gone through some, smaller earthquakes. They haven't gone through a big one. But he said they're hands down the best. And these are, so you got to look at with foundations in general, you got to look at them two different ways. You got the foundations that are a foundation, but you're with no living space below. You basically got a slab of some kind, which is a good part of the country. And then you have the ones with basements. So the ones he built were all with full foundation basements, which in his part of which in many parts of California are not the norm to have full basements underneath the houses. So those ones he built were indeed for that.
Well, there certainly is something to say about the built-in flexibility with a wood structure over something that's concrete. I mean, the seismic argument makes perfect sense.
Yeah. We had a few comments about alternatives to the pressure treated plywood. Could you use MGO board? Could you use aluminum stress skin panels? It kind of sounds like defeating the purpose of low carbon, low cost, but MGO
there's tons of ways to make it more expensive.
Yeah. I mean, is there an MGO board that could hold up to the soil pressure? I don't think so.
If somebody did the testing for it, they could probably find that it might work, but I don't know enough about it. I'm like a regular contractor. For myself, I just use prescriptive tables and charts and diagrams. But yeah, it's a good idea if somebody could figure that stuff out. But that would be necessary if you are having a full foundation basement where you want space underneath or behind the wall below grade. If you are backfilling on both sides, then you could pretty much use anything as your sheathing because you don't have that concern about the soil pressure or unbalanced soil pressure.
This is where we need Chris and Phil to chime in with their 6-digit idea for some recycled plastics panel that can be applied in lieu of the plywood that is the termite food. Because to me, that's really the only weak point of the system. Like everything else about it, you're like, oh yeah, I like this. This is good. If you frame it right and you deal with the water management and the soil pressure issues, then it's just about the rot. And once you solve for that, which of course you can do with the slab, as you said, but in the Midwest, we do basements. So I'm arguing in favor.
Well, you go far enough north and the termite argument goes away, right? Right. You build where Randy lives and the termite argument goes away. And so Mike, isn't the arsenic and CCA there for bugs as well?
Yeah, I guess so.
I mean, if you were going to order CCA.
An interesting sidebar to the CCA concerns, the building commissioner that I talked to, Joe Cirillo, back in the mid-1980s, he said that was one of the concerns that people brought up is what if you build these permanent wood foundations and it was left, the pressure treated wood was left exposed inside the basement and children went around and touched it and licked it and all that. So they had it's
called natural selection.
Well, you say that, but his description was they asked the question of somebody who was they had a professional come in who did a calculation of how much surface area a 3-year-old child, the height of an average 3-year-old, could lick before their tongue fell off out of their mouth. Actually bled so much that it fell off. And they said they wouldn't be able to lick enough surface area to get enough arsenic in them to make a difference. The problem with arsenic is a little bit different.
Sounds like a challenge.
If you go back and you read all the EPA stuff from back in the early 2000s about what the issue with arsenic was, it really wasn't as big of an issue in most of the country. It was only in certain parts of the country where it would leach out and get into the soil. But where you have active soils, like we have in the northern part of the country, biologically active, that the arsenic ended up being locked up in the soil due to the soil conditions. So, but anyway, that's neither here nor there. If I had the choice, I would go for the CCA, because that stuff is, I've got some boards from the 1960s. I got to do an Instagram post where they've been under the leaf litter, just under the leaf litter, and they've been there for years, and they're still perfectly fine. Just brush off the surface dust, and they're ready to work.
The argument for CCA, when I did a little bit of research because I knew that I was going to be with Mike and Mike would know his stuff. It's not like presenting with Steve where you can just wing it. One of the test houses in, I think up near Randy in Minnesota, maybe, they did the foundation out of creosote treated logs. Mm-hmm. And I was just like, oh, that's a great idea to let people live next to the creosote with indoor air quality, but I bet it's still there.
The original, that 1936 or 37, first time they did the permanent all-weather wood foundations, was done with creosote-treated lumber.
Yeah. I mean, it's lead paint, right? I mean, we did what we knew worked. We weren't concerned as whether or not it hurt the people that were living there.
I've seen a couple of questions that have buzzed by that caught my attention regarding, or comments regarding either the air quality in a basement due to the pressure treated lumber and or the soil gases, primarily radon. And all of those can be managed the same way you would manage them with concrete. Even concrete, you're going to have some problems if you don't have good blockage of air. Most of those soil gases anyway are going to be coming through any gaps, cracks, joints, so those can be taken care of. And even the wood framed floor system in a permanent wood foundation basement shows a completely sealed poly that goes over your sub base for your earth, and then that would be the same thing you do with concrete. We put down the plastic, pour the slab on top of it, and then that's plastic's doing a lot of the work.
And you can pair that with operating the house under slight pressure.
Yep.
You can mechanically take care of it. Mm-hmm. So somebody asked if you could put Zip or Advantech down there if it's properly detailed. I think the idea behind all of this is that we're putting stuff down there that's okay to have a little bit of moisture against it long term. We're putting stuff down there that's rated to be against it. I mean, obviously, if you're not letting any moisture get against it, then it doesn't matter what you put down there. But that's a challenge that's not part of the code.
If you're going to wood frame the floor inside of inside of one of these permanent wood foundations, that real technically doesn't need to be pressure treated. That could just be regular frame lumber. So you could just be whatever you put down for your, floor deck, so to speak, could be the same thing you do with a concrete free slab over insulation. You could just do it.
But Mike, at that point, you're inside your poly though too, right?
Yes, you are. Exactly. Same point you were just making. Yep.
Yeah, we're not outside.
Yep.
Earlier, Patrick had asked if we shouldn't be thinking of the walls as perfect walls with the insulation on the exterior, and I know Mike, you showed a couple of options with that, but with the more conventional approach with the insulation in the framing cavities, I mean, this is kind of like the same thing above grade. We're concerned about vapor and dew point and all that stuff. Is it the same issue below grade? Is it a different issue? Is it more of an issue? What do you guys think?
I think it would not necessarily, I don't think it's going to be a lot different than above grade, provided you're managing the bulk water in the soil and you don't have real high, very poor, if you have well-drained soils and you don't have a problem with water table is going to be a problem anywhere anyway, no matter what you build for a foundation.
Right.
So I don't think that if anything, when you think about it this way, depends on where your climate is. In my area, we have a 52 degree temperature once you get below, I think it's like 3 or 4 feet below surface. So at that temperature now, and if you're heating your interior of that basement, if you finish it to 70, your delta T is only 20 degrees. If you manage the moisture content of the air inside inside the basement and keep that a reasonable relative humidity, you're probably not going to have a big condensation potential on the plywood, even if you don't have a lot of insulation on the outside. Once you add the insulation, it'll be probably even better. Now, I've screwed things up plenty of times before, so don't take my word for it. I'm just winging it here.
That's what, that's what it's all about here, is winging it. What's that, Kylie?
Well, I was going to ask Mike if he could talk about some of the screw ups. What are some of the things that are definitely, don't do this kind of stuff?
With regard to?
Any of the detailing that could make this go awry. I don't know.
Well, the one thing that I did notice, because in my father's shop, is we just jammed it full pack with some R19 fiberglass. Don't do that. It's the inside face of when I pull off the plywood panels that are on the inside of the shop wall and I look at the insulation, it's been getting wet on and off for years. Now, of course, the space is not heated or conditioned in any manner, and he's at a high water table, and there was no plastic under the 8-inch concrete slab we started with. So I think it's just comes down to poor water management, because all we did was the basic, because it was just a shop to work on cars. So if you did better water management and used the exterior insulation, and then be thoughtful about how you detail install the interior insulation, if any at all. Do you really need a lot of cavity insulation if you put enough insulation on the outside? If your difference in temperature is only 20 degrees from your ambient ground temperature, maybe you don't need to bother with any cavity insulation, avoid that altogether, and you don't have that problem to deal with.
Interesting.
So I make a big argument constantly about let's not put insulation on the outside of the foundation, because we can't inspect it, we can't replace it without digging things up. But I think that if you're willing to go, I think that we're all talking about, I keep looking down to remember how you phrase it, raised ranches. I don't think we're talking about full basements. If we're talking about a raised ranch or a split level where we're burying 4 feet,
yep,
that's a completely different thing. If you're willing to put pressure treated lumber below grade in that case, then we're relying on pretty substantial detailing at that point. And that's a different thing than insulation on the outside, but that still hurts on some level, the idea that we're just going to bury it. We're just going to bury insulation where we have no control over it, or we have way less control over it.
So this might be a good time for me to show my proposed detail, which includes exterior buried insulation. So Jake will be happy.
Ooh, is this the part of the show where we pick apart details?
Yes.
Hugh
So
Steve.
What's that?
Yeah.
Hugh Steve Basic in the comments. You're going to fire him up.
Yes.
Show us the details.
Yes. Yeah. Here we go, Steve. So this is a concept for an addition to my own house. I think this will show. Are you seeing?
Yep.
Seeing a slab detail. So I designed one of the first concrete free or reduced concrete slabs. I still had a concrete perimeter beam at my house. This is an addition for the back. I have an 1830 cape, which is dry laid rocks just stacked up with some granite and some bricks, and then a timber frame. And it's too small, so we need more space for a kitchen, and access is really bad, and I am frugal. So I'm trying to think of a way to frame this efficiently, and while I'm at it, just reduce carbon and just see if I can do it without foam or with as little foam as possible. So my idea is basically a crushed stone footing stacked up, pressure treated 6x8s instead of a framed wall. Just I thought that treating it like a landscape timber retaining wall would make sense, with layers of gravel, layer of mineral wool, heavy duty vapor retarder over the mineral wool, and then set 2x8 joists directly on there, as opposed to Mike showed the idea with the overlapping Advantech, which is another way to do it. The one I did, we did Advantech over sleepers. This is turning it on edge, which gives us the opportunity to run some things, so run plumbing in the floor system where it's not buried. On the outside of the 6x8s, I have mineral wool with stow parging, and then just the wall is a 2x4 wall with Gutex on the outside. But yeah, that's my idea. Obviously, I'd connect the landscape timbers well. Probably have a few dead men coming back in to hold it in place. The floor framing would tie back into the house, so we keep it from rolling. So yeah, what's going to fail? What's wrong with this?
I got one. Why not just do the below grade frame wall? The 6x8 timbers seem to be complicating it in a way where you're introducing, like you already said, like you addressed it subconsciously there. You went, okay, well, but I do have to worry about that rolling. Why not just do the frame wall?
Mm-hmm.
Yeah.
It's probably cheaper.
I think before I drew it, I thought I would need like 3 beams. And as I drew it, I realized that as grade falls away, I'm going to need more like five beams. So no, a framed wall would make sense and use less material, and pressure treating doesn't usually get to the middle of 6x's very well. So I like that idea. That's it. No, I can't see the chat box right now.
You didn't see the chat box. Steve said get rid of the exterior insulation and live happily ever after.
Get rid of the exterior. Well, so the exterior insulation is because I wanted to do this frost protected. In Maine, we have to go at least 12 inches below grade with exterior insulation. The frost wing isn't technically required where I am, but I think it's good redundancy and directs any water to a drain that's away from the footing that would go to daylight. So that's the reasoning. Or did Steve mean exterior insulation on the above grade wall?
I think he meant he said move the 6x8s out and eliminate the insulation. The floor insulation connects to the wall insulation.
Yeah. But just if I do that, I have to go below the frost line, which where I am, I'll hit bedrock first. So I need the exterior in order to do a frost protected shallow foundation. As far as I know, unless Mike has another idea, because Mike's more of a frost protected expert than I am.
Well, you can. You don't necessarily, if you hit bedrock, then I don't think you have to go. You only have to go to bedrock. So even though you wouldn't get to your frost line, that would be sufficient because you're on bedrock. It ain't gonna move.
Right.
If it moves, we're all in trouble. So you could dig down further and then backfill with as much crushed stone as you want. And then you don't have to worry about the wing wall insulation or anything, because essentially you've got a foundation which is going to frost line once you get to that level of the bedrock. Of course, that's more digging. With what you've got drawn there, you could probably dig it all by hand, because it doesn't look like you're going much below existing grade.
Right. So this is a tough place to access. So this I could get there with a mini excavator or a small farm tractor, or dig by hand, but I can't get there with a big excavator. So yeah, that's part of the thinking, is trying to get there.
Yeah, then just go shallow. And I wouldn't waste my effort with the horizontal insulation if it's not required.
Okay.
And it's only based on my experience. I own a bunch of old houses built in the 50s and 60s where they only went down with the foundation down about maybe 8 or 10 inches in some pretty crappy soil. And I thought they were, had put in frost walls in these walkout basements, but they only went down a few inches. And it's perfectly fine. They've never moved. No evidence of cracking in the concrete, no evidence of, and this is hard coat plaster, the old gypsum base with a half inch of rough coat and then a skim of veneer plaster. Those things are prone to cracking if they had any sort of movement. So with that, and your climate isn't that much different than what we get here in the winter. Yours is just a longer period than we get. Our frost line's down at about 40 inches, 42 inches, so yours can't be that much lower.
Yeah, ours is 48. We have about 7,500 heating degree days, and the air freezing index is between 2,000 and 2,500.
Yeah, so it's not.
So it's just a little worse than yours. Yeah. No, that's good.
Mike, if you're worried about water at all, like surface water, you could, we've been thinking about for a while now, taking a piece of EPDM and attaching it to the wall and laying it on the surface and then covering it with rocks. Just kind of like, you don't want planting close to the house anyway. So if you landscape that, it's kind of like putting in a little buried gutter.
Don't laugh, Jake. We've done that a number of times on retrofits where they have a water problem and they don't want to dig more than 3 feet out. And so we, dig a little bit, put some EPDM down there, just suggest it goes somewhere else.
It's one of those, I can't believe I never thought of it before.
3 feet down, 3 feet out. It's a nice little gutter system.
Hey, Mike, are wood foundations something that you're out there advocating for? Is this something that you feel is the way to go in most cases?
You asking me?
Yes.
Nope, I have no bone I have no skin in the game on permanent wood foundations. I'm just familiar with them. And then when Mike Means asked if I'd come on and talk about them, because I guess, Mike, you had seen might have wrote something about it. It won something in one of my posts.
I think so, yeah.
Yeah, and I've explained my experience. I don't know a ton about it. If you won't, but I plan on using it on my own next house, just in the fashion I showed, similar to what Mike had. And it's mainly I can do it all myself. I don't have to call a concrete guy. I don't have to get a pump truck in. I don't have to order from the batching plant. I can do it little sections at a time. It's not for everybody. I find a lot of things in the code book are curiosities. In fact, when we do that's what I find that permanent wood foundations, it's like a little niche curiosity thing. And I think it's good to get the ideas out there because a lot of people aren't familiar with it and they don't want to touch it. And with just getting a little bit of information, if 2 or 3 people walk away this afternoon and say, hey, I'm going to give that a try because this could be a perfect solution for such and such a job, then we've done our job, just in elevating the awareness, I guess. Mm-hmm. I don't know if that answered your question, but
yeah, just curious. Is it, a viable option to reducing the use of concrete, or is it just fringe?
It's so interesting that I never until probably 10 years ago thought about any impacts of concrete. I thought it was like the most perfect building material. And at the time, 15 years ago, I was building ICF houses, from below grade to 2 or 3 stories high, because we thought concrete inside insulation, you can't go wrong. But now is the awareness of how much energy it takes to make concrete is becoming more of a concern for a lot of people, rethinking some other alternatives. And when we do the summit next week, I've got a little insight session. I'm going to show some other cool things that are in the code, like the crushed stone footings. Crushed stone footings, you don't have to, if you're going to do slab on grade and you don't want to deal with permanent wood, you can go crushed stone down 3-4 feet, no concrete involved. Rubble stone foundations, still in the code book. You can still do rubble stone foundations. So we can go back to bedrock, bedrock in terms of Flintstone bedrock. I don't mean bedrock as in you have to dig that deep. So you can still use rubble stone foundations. Go figure.
I will say that I think when Travis and I talked about this, I think it's 6 basements that I've lived in my life, and only one of them was dry, and it was built out of wood. And only one of them has been old. The rest of them were new when I moved into them.
Do you think that's a credit to I guess when you're building a foundation out of wood, you feel like it's extremely high risk for moisture.
You get more panicky.
So yeah, like I'm going to detail this really well to make sure this is never a problem. And if we would just do that with our concrete foundations, do you think the basements you had would also have been dry, or do you think the capillarity?
Think so.
Okay.
Yeah. So I think first of all, that basement on that split level on that raised ranch was only 4 feet below grade. So it had the best possibility of, it started at a better point than, say, the one that I'm sitting in now that I'm 7 feet below grade. But my pop said that he backfilled with 2 feet wide of gravel all the way up to about 6 inches below grade. And boy, that's a lot of pressure relief.
I promoted Mason Lord, who is a builder in Connecticut. He's working on a few old barns and had sort of a different wood foundation idea, more like a sleeper system. But do you want to share your sketch, Mason? We'll critique yours.
Yes. And I'm like Michael, I want to hear feedback and tell me where I'm going wrong here.
Is this at that same property, Mason?
No, this is it's 3 different projects. So there's the red barn, the brown barn, and the new barn. And I'm going to start with the new barn because that's a little more straightforward. We're trying to put wood floors into all of these structures so that we don't have to use concrete. So in the new barn, the idea is we'll have traditional concrete walls. The pressure-treated 2x4s will sit on a ledge here, run across, sit on a pier in the middle. So basically sleepers on top of crushed stone with then a wood floor. So here's the detail. This is the wood floor on the top. The pressure-treated 2x4 gets fastened to a plate on a ledge on the foundation. This is a new timber frame barn. The PT half-inch plywood right directly on the concrete. And then the sleepers get held up by a center wall as well. All 3 of these buildings are non-conditioned spaces. So the red barn is a mid-19th century barn. The homeowner would like to store cars in the barn. And our idea, same way with the brown barn, except they don't want to put cars in it. It would become a storage space. The existing floor in here is a combination of asphalt and concrete. Here it's dirt. There's center piers that are supported by stone sitting right in the dirt. So the drawing is, what we've got is a pressure-treated 6x8. In the center here, there are 3 piers that will support the posts that are the main timber frame support for the floor system and the roof system. So not tongue and groove flooring, but square edged flooring. The 2x4 sleepers on top of crushed stone, a vapor barrier coming in. You know, that's one question. Where does the vapor barrier come in, and where is there a problem with water potentially sitting on that vapor barrier? We're going to put sonotube footings to support the posts. But basically, it's a timber frame, pressure treated, floating floor system that we're looking to put into the red barn and the brown barn. And just so people who have cars, I've advised the guy that it's not going to be a good place for cars if you don't have a car capsule, some way of taking the air and exchanging it so that the car can survive through rust and rodents and all of that. So I want to hear feedback on what people think about this floor system. Where are the failure potentials?
We have a Jeff Sumas, a builder here in Maine, says you need a vapor barrier below the gravel, which is kind of what I had expressed concerns with, was just that you could have some ground moisture coming up through, and it needs to get through the plank flooring.
Right. So where is he suggesting that the vapor barrier goes? Because one thing you had said, Michael, was that if we put it down at the soil level, that we could create a swimming pool.
That too.
Have you thought about concrete?
Mason, Steve wrote that you should put the vapor barrier under the wood and above the stone. I think that's what he said.
Okay. So
yeah, by putting it above some of the wood, you're excluding that wood from being protected. And while it is pressure treated, if you're going to go to the effort to put down poly, use the poly to protect whatever you're putting down.
right. So are you saying put it right now? I've got it in the drawing, the blue line here, right above the main frame, but below the pressure treated 2x. So you're suggesting raising it up?
No, it should go below the 6x8s.
Okay.
In my mind.
Okay.
I'd love to hear what Mike Girton has to say, though, since he's one of the panelists.
Well, I've been trying to figure out if this would work. So, Mason, where are you located?
We're the northwest corner of Connecticut,
Okay.
Litchfield County.
So you got warm, humid summers, and your soil temperatures are like mine. They're probably in the 50 to 52 degree. So in the summertime, if you put that plastic down without any insulation, then that's going to be a condensing surface in the summertime. So I wonder how those planks are going to deal with the moisture that's going to collect on the backside of those planks if you put that vapor barrier right underneath the planks.
So what I'm hearing you suggest is that it should be on the top of the soil.
Well, actually what I'm thinking is it might be worth putting a layer of insulation in there somewhere in the sandwich, just so it's a little bit less likely to get condensation no matter where you put it.
Mm-hmm.
I don't know if
that layer of insulation makes it so that the ground temperature and your air temperature aren't fighting anymore.
Right.
Or they're fighting less.
So I have a little experience with this. This would be where they're going to store cars?
Well, one of the projects he wants to store cars. The other would be a storage space,
okay,
but a clean, nice floor system.
Okay.
Conditioning things also helps make them clean and nice too.
Yeah, I know, but this is,
Old buildings are tough, though.
yeah, we're not looking to condition, but we're trying to eliminate the concrete.
Yeah, I think I had mentioned that maybe skip the vapor barrier, drop your crushed stone down to the bottom of the six bys, sorry, and just leave plenty of airflow. So the 6 bys are sitting on compacted crushed stone. Add more than maybe 2 or 3 feet on center, then run your planks across the top. Make sure there's some gaps between the planks. So just you're encouraging some airflow. You still could get some condensation, but if you have a good layer, and if you're using like white oak planks or something that can deal with moisture, that maybe that would work.
So
look at that.
Creating basically this whole area here is air. Is that
exactly? That's what I'm suggesting.
Yep. Okay, so then maybe the crushed stone goes down 12 inches there.
All I'm learning so far is that 6x8s must be way more common on the East Coast than they are in the Midwest, because I don't know if I've ever seen a 6x8 at a lumberyard.
Well, so, or Jake, honestly, I had been planning on 6x6s. Mason asked me about this last week or 2 weeks ago, and I said, "Oh, 6x8 is better because you get more width." So I only did 6x8s because Mason did.
Well, we can get 6x8s here. So, and we use them to replace in timber frame houses the sill beams, pressure treated 6x8. So.
Bezek weighs in with he would do 3/4 inch stone on top to the top of the 6x6. So like you have, then add 2x4s on top of the 6x6 to install 1.5 inches of 3/8 stone. So you're sort of creating a screed layer. Those 3/4 are better. Yeah. So 3/8 stone is a screed layer. So he's
yep. So
he's saying fill it up, but yeah.
Well, it sounds like I'm getting a whole lot of different opinions on this one.
That's the nature.
Well, you know what they say.
That's the BS.
Clear as mud.
Yeah. All right. Well, thank you.
That's a tough one, Mason. That's the second you add in, we're not conditioning it, and we're going to park cars on it. It's like, I don't know, gravel.
Don't forget about the bubble, the air bubble for the car. That's going to save the car. So we're not looking to keep the car protected by this. You have to put that into, those car capsules exchange the air like 3 to 5 times an hour. So.
Are you looking for one solution for all 3 barns? You do the system for all of them the same way?
Well, the new barn will have a concrete foundation. For the 2 antique barns, though, yes. Yep.
Well, I can send you the chat box, Mason, if you want to review what everybody waited with.
Oh, that's pretty cool that you can do that.
I can do that.
Don't put anything in there you don't want her sending to somebody else.
It is recorded.
Noticing, since I went on, there's 48 new chats.
We should have you on more often.
What else do we have? Or one question I had from earlier. I think somebody else had asked it, but I was curious too. In the codes, do they, with the crushed stone footing, and I'll try to be careful because Lewis says that we shouldn't use gravel and crushed stone interchangeably. So for the crushed stone footings, or the footings in general, wood foundations in general, are there limitations, or do you for different loading, different size buildings, different number of floors? Or is it pretty much a 6 by 16 footing is going to handle pretty much anything?
That'll handle up to a 2-story building. Once you get outside of the prescriptive IRC measures, then you're going to have to move to that American Wood Council permanent wood foundation specification, and then it's all engineering at that point. So you'd have to do, loads, soil bearing capacity, and then just build it up from there. Lateral loads, vertical gravity loads. I know the principles. I don't know how to do the calculations.
I thought one of the interesting things when I was, because this isn't part of the code book that I had explored before, but I spent quite a bit of time with it this week. One of the interesting things that I came away with was our houses don't weigh that much. Like our wood frame structures, residential buildings don't require an enormous footing, and they can't weigh that much if they don't, require a huge footing.
The interesting thing, though, you say that you're right, the building itself and all the materials we use to build them don't weigh a lot. But the way the code's written is we have to design for the live loads, assuming that you've got this uniform live load across this whole giant floor that you have 2 people living in. So 40 pounds per square foot over 1,000 square feet is a lot of weight that they anticipate as a possible worst case if you had a really big party. But the chances of ever getting there are super rare, especially if you got a family of 2-4 people. You're never going to see the real loading that the house is designed for when you follow the tributary loads all the way down. There is so much built into all of these prescriptive measures with everything in the code that we'll never get there.
You got to have one of those crazy Mike Gurton parties to really load your house.
What, party of one? That's all I read.
Party of one.
But at least it goes all night. At least you're up all night.
Water.
That's
Can go
right.
all night
I was
with
going to say water is super heavy though. So if everybody's drinking a lot of water, that's a wild party at the Gurton house.
8.9 pounds per gallon. Well, I think we're coming up on our 7:30 time. Do you guys want to? What would your parting thoughts be? Well, what do you think our audience members and other panelists should go away keeping in mind for wood foundations?
I think it's really interesting. Good luck selling it to a client.
Well, how might you sell it, or do you think it's absolutely hopeless, or is there a specific client who might go for it?
I think the full foundation wouldn't be on the table for me. I think that a partial foundation, partial in ground, a raised ranch, and I think the Nerdville client is the client that it would be sold to. I don't think that it's going to be sold to somebody that just comes to us because they want durability or they want a house that is the aesthetic that we like.
Sounds good. How about you, Mike? Any parting words of wisdom?
I think I parallel what Jake said. I would use it for those raised ranch where you got a partial foundation going down below grade, partial living space below grade, or I'm really thinking those frost protected foundations like what I'm thinking of doing and what you're thinking of doing. It's just like, why not? There's no downside. You don't have any lateral soil pressures that you'd really be concerned about where the basements would have that. You don't have any moisture problems where you want to make sure it's all waterproofed and that. And yeah, I think it would be valuable.
That's good.
When are you going to get started on that, Mike? Both Mikes. When are you guys going to do those things?
Mine, in theory, maybe late next year, probably the year after, more realistically.
Well, make sure you document them, right?
Oh, I will.
Okay.
Yes, I'll write about it, blog about it, Instagram about it. No, it'll be fun when I can get to it. I just need to get some things done. Well, thank you, everybody. Thank you to our audience for hanging in and participating. It was an active chat. Thank you, Mason, for jumping in and sharing your ideas. And, of course, Mike and Jake, and Mike especially for your very thorough and but still pleasantly brief presentation. It was great. So,
And
You're
my
welcome.
my parting shot is
yes,
that
Mason. What's your thought?
I'm very happy that this is all clear as mud.
Yes, you got what you paid for. How's that?
I was thinking instead of an answer, you just got more questions.
All right. Have a good night, everybody.
Thank you, guys.
Good night,
Thanks
all.
all.